Folks, good morning. You can do better than that. Good morning. Yeah, it's evening. I mean, you got it. So as you already know, I'm from Brazil. I'm specifically from a city called São Paulo. How many of you have heard about São Paulo in the past? Nice. Actually, some fun fact, São Paulo is the biggest city in the whole southern hemisphere. So we have like 22 million people, and that's a freaking lot. And with that, we have a lot of different stuff. We have traffics and a lot of people going by. And it's good to be in Lille, where it's a little bit more calm, and I have time to rest a little bit and meet a lot of great folks. So how many of you have been in Takeoff before? Nice. That's really nice. I think I have been in all years since the beginning. I'm not sure, but probably since 2013. And that was crazy cold. I'm so glad that they moved that this summer because right now we have like good weather and it's not even raining. So thank you for that. Well, I actually want to start with a story, and I started about myself. And all starts back in high school. I was already programming, and I was actually not even programming. I was actually on a job. I was actually programming as my career, and I was having a lot of good time with that. But because I had high school and I had a job, I wasn't have too much time to hang out with friends. So I wasn't hanging out with my friends, having fun, or none of that. And I remember some friends were doing like a party, and they would have like all sorts of fun stuff that you could do in there. And they said, you gotta do, and you gotta go for it. And I went. And getting there, they had a trampoline. And I said, all right, I'm gonna do it. I have to jump it. So I went for it, and there was a small line, and I wait for my time. And when I got to my time, I started jumping like crazy, and I'm like, all right, I'm gonna rock star this shit. I'm gonna do a front flip. And I went to do the front flip, and once that I did that, I fell, and my knee hit straight in my chin, and I broke my jaw. That is actually a photo of my jaw after the surgery. I end up with a plate and 4 pins in the face for the rest of my life because of that shit. And that was fun. I mean, don't get me wrong. But after that, I had a long recovery period, like 1 year to get back into talk normally, eat normally, and all that. And that was a struggle for me because I had to stop working and stop going to the college, stop going to the high school. And I almost lost a year studying and all that. And I was really down. I was like, I didn't want to do anything. I was kind of depressed. And I remember back then, my father, fun fact, he is here with me today. My father told me, pushed me aside and tell, hey, I have something to tell you. Don't settle for untapped potential. I mean, you have so much potential, so much stuff that you could be doing, that you were doing. Don't settle for that potential that you haven't still tapped into. And that was really profound to me, and that was a lesson that I took with me to every job and every project that I worked at since then. So every new project, every new job, I was always asking myself, all right, so where is the untapped potential? What is the potential that this company has, that this project has, that this app has, that is still not being explored? And I want you to hold to that thought for a bit because we're going to go back to that in the middle of the talk. For those that doesn't know me, my name is Moura. Americans call me Joao, so that's fine. I'm an engineer manager and a speaker, currently working on TopTal. How many of you heard about TopTal before? Nice, not that many. So we are basically a freelance network. So we have around 4,000, 5,000 freelancers on our network, and we provide services for backend, frontend, mobile, product manager, and all that. So moving on. I was working on this project that I can't tell the name of it, but it was basically an e-commerce. And as an e-commerce, we struggle with sales. I mean, we always are pushing to sell more, to having better margins, to have more revenue. But we had a different issue in this project. We are growing insanely crazy fast. So we are growing like 20% every month. And that has been that way for like 1 year. So 20% this month, 20% next month, and month after month growing and growing. And that might be like, hey, that's awesome, right? That's the dream. But actually, when everything's growing is not only the revenue. I mean, you are growing support, you need to grow your inventory, the number of bugs will grow as well, the number of users. So if you're not prepared to that kind of growth, it can actually be a waffle situation because you can't really take advantage of that growth and enjoy that, and that is just wasted potential. So I remember that we're trying to figuring out what should we do about that because we are being reactive instead of proactive. We are not actually trying to enjoy this growth the most that we could. And we couldn't even set proper goals because we don't know how much revenue we would have next month. So how much should we scale the teams and all that. And that'll become a crisis. And I remember back then, the company didn't believe in data science. They had no data mentality yet. And I choose that challenge to myself. I said, all right, I'm going to learn data science, and I'm going to figure out how data science can help us, because that was untapped potential that we could take advantage. And I set myself to answer 3 questions that I believe that would help us to actually take full advantage of that. That was how much money we will make, who are our clients. I mean, we know who they were, but how we classify those clients. And the third one is, can we forecast a customer quality? So we know that we have good customers that have been buying for us every month, but as the user gets to our site and do his first purchase, can we forecast if he's going to be a good customer or if he's going to be a low quality customer? That's something that we need to figure out. Before I explain how I solve that problem, I need to do a data science 101 real quickly. So how data science works? I know it seems a black box. Everyone knows that it's pretty awesome, but it also seems really complex. It's not that complex, but so let's understand a little bit how it works. Imagine that we are trying to figuring out an algorithm that is going to predict film, like movies that you are going to like. So basically, you start with a bunch of data. And let's suppose that in this data, we have the year that this film was produced, the actors in this film, and the IMDb score. And also if you like that movie or not. So we have all this data from, let's say, 1,000 movies that you watched. So the first thing that we do is that we split that into 75% is going to be what we call training data, and 25% is what we call testing data. So we get this at 75% first, and we apply some machine learning. And machine learning is extremely easy to use, and I can prove that. Basically, what the machine learning will do is going to try to figuring out how this data relate to each other. So how the year, the actors, the IMDb score are related and result in the fact that you like or you not like a movie, or how much you like a movie on a scale from 0 to 10, let's say. So you can have things like, let's say that when checking the IMDb score, you will realize that you have a linear relation. So as higher is the IMDb score, more you like the movie. But there are things that are not so straightforward. For example, the year. Let's say that you really like movies that are old. You don't like that much movies that are kind of recently, but you love movies that are pretty recent, that are brand new. So the relations are not always linear. There are different kind of relations. That's when machine learning comes into play, to figuring out how those relationship works and give you something out of it. So basically, once you take our data and apply machine learning on it, you're going to have what we call prediction algorithm. And then you get to those 25% that we had spare, and you're going to try to predict like if it was new data. So you're going to take that, or you're going to remove the information of how much you like it or not, and you're going to pass through the prediction algorithm. And the result is going to give you what we call cross-validation score. That's how much of those movies that you had spare to test, actually you got it right, and how much you got it wrong. That's basically it. I mean, that's data science 101. It's not that complex. So let's go to the questions that I was set myself to answer. The first one is how much money we will make. That is basically forecast the next month's revenue. So what I did is I got all the orders that we have and I tried to understand, and that's the initial part of data science, is start to understand the relations between the data. So I start to do some graphs. The initial graph was plotting all the orders that we have per month in a year. And then you're going to realize that we are starting to building up a little bit on those orders to the end of the year. So January, February, March are really pretty shallow, but they are building up until October and November where we sell more. So the month is actually an important data when trying to predict how much money we're going to make. And then I plot all the orders that we ever had since from the beginning of the company until up the point that I was still in the company. And you start going to see some patterns in there as well. So every December, you're going to realize that we have a shallow and we have a drop in the sales that we have. So that's another thing that we need to consider. So there's also that. And you can also see that the orders is always building up, so we're growing. That is another thing to take into consideration. That is our real data. It's because it hadn't finished the month yet. So we are like in the beginning of the month. No, they're not crashing. So, and if you grab that, if you try to gather that by season, you're also going to realize that the fall, we sell way more stuff than the spring, and there it goes. So I keep doing some exploratory analysis to understand how this data relate, and they're figuring out some stuff pretty cool. Like, it's something that might look obvious, but the current revenue is really influenced by the last month orders. So if you had a good month, the chances are that the next month, you're going to have a good month as well. And if you had a bad month, the chances are that the next one is going to be a bad month as well. So that is another cool data that you need to take into account. How was the last month's revenue? And when you plot all the data that you have like in a year, that's what we call a autocorrelation table. So it basically says how much 1 month revenue is related with the second, the third, the fourth, and there it goes. So the point where you see that it's almost 0, that's 12 months. What basically means that if January is a good month to us, the next January is probably going to be another good month to us. If December is a bad month to us, the next December is probably going to be a bad month for us as well. So what I did is I got all this data, what month it is, what season it is, last month's revenue, the amount of money we spend on advertising, and the last year, same month revenue, and apply the linear regression. That is basically the most simple algorithm that we have. And the results was pretty cool. Oh, my bad. The results was pretty cool, but not good enough. Basically, like what you can see is the blue is the revenue that we had, the red one is the prediction, and the yellow is the difference. So September was kind of okay, but you see that October and November, the algorithm was not able to predict that really good. So I decided to do another technique, a little bit more complex, using another machine learning algorithm that capture other kind of relationships that are not linear. That is basically build what we call a decision tree. So imagine something like that. The name of this algorithm is gradient boost regressor, and I'm going to explain that real quickly. So imagine a decision tree. So like, is June? If it is June, have we spent more than $1,000 in ads? If we did, then our revenue is supposed to be 100K or 120K. And if it's not June and we spend and we made more than 100K last month, then you're gonna have 80K or 200K. This is just example. So it's basically a decision tree. But the problem with decisions tree is that how you can predict a number that you haven't seen yet. So if we're growing, how can we predict that we're gonna do like 500K or 1 million if we have never seen this number in the past? And there is a really quick get in here. That is basically you can estimate the difference instead of estimating the actual revenue. So how much you made this March less how much you made last year, this number always fluctuates the same because there's a pattern. We are growing. So it's always fluctuating between, let's say, 200K and 500K. So basically estimate the difference, and then you're going to know how much you're going to make the next year. That's what I did, and the result was pretty crazy. As you can see, we were able to narrow down November, and since that, I have been following the algorithm performance, and as far as I know, we are getting it right in like with a 5% margin. So it's pretty awesome. And now we're able to know how much money you're going to make next month. The other question that we had to answer was, who are our clients? So we know who they are, but how do we classify them? So all that I had for this was basically the emails of those clients. I don't have much information on that. So I used a service called Clearbit that is basically an enrichment service. They take an email or a domain and they enrich that data and give you all sorts of information like how many clients this company has, where it's located, if it had an investment and how much the investment was, those kind of data. So with the users' mails, I was able to get data like the state, the country, Alexa rank. Alexa rank is basically a rank from every website in the world and how popular they are. And the customer orders. So I have the history of all orders for that customer. So what I did is I used an algorithm that basically clusterify the customers. And here you can see by different colors how they're clusterized. So there are basically the blue ones that are the ones that do not buy that often, and even when they buy it, they don't spend that much. And you go up to the yellow ones that are the ones that buy way more often and spend way more money. So that can give you a relation from 4 different clusters that we had: the blues, the purple ones, the blacks, and the yellow ones. And it's good to see some relations between those clusters and their buying habits. So you can realize, for example, that most of on the top right corner, you can realize that most of the yellow customers, the ones that are the best customer for us, usually have a first order that is really low. I mean, that's really cheap. They don't buy a lot. But the blue ones, they're actually bad customers or low quality customers, have like huge orders at the first orders. So there is definitely some correlation in there. And another cool fact is to realize that the best quality customers always buy in the last part of the year. So they're not buying in January, February, but they're buying after July and the months following that. So that was another good thing that made us realize when we are getting good customers and what kind of customers we have in our platform. And then I went to the third question. So can we forecast a customer quality when before he actually does those more orders with us? So in order to do that, there's a problem because usually when you're talking about best customers and like high quality and low quality stuff, you're gonna have a lot of bad quality and low quality stuff, and really only a few or a handful of really good quality customers. So if you try to do a machine learning algorithm on that, basically the machine learning algorithm will always gonna predict that the user is low quality. That will give like a high score that's gonna figuring out most of the times that it's a low quality customer, but you won't be able to figuring out when the customer is really good and then you actually want to pay attention to that customer. So I use a technique called Smote and Tomac links. Basically what it does is it creates fake users, like fake data that looks similar. That way you'd have as many good customers as you have as bad customers, and then you can apply an algorithm on that. So in order to do that, I built a decision tree, the same thing that I told you before. So basically, a set of answers, the yes and no questions, follow it together. And in order to build that tree, I decided to build that, like the best score that I was able to get was 27 nodes in. So that means 27 questions in. And this is an example of that tree. So whenever a customer like buys something, it goes through this whole tree, answering a lot of questions about this customer. So is it from US? Is it not? Is it from Ohio? Not. So is it from California? Not. Is the Alexa rank bigger than like 1000? Yes or no? So it goes through this score, and I was able to get a cross-validation score of 7%, and that is really awesome. So it basically means that I was able to get 7% on every new customers that I was getting it right. And the split test score, that is basically that 25% that I had spare, was an 89% score. But I went a little bit further, and I used another technique called add a boost classifier. What it does, and there's something called assembling. Basically what it means is that it's going to build not one tree, but a lot of different trees with different questions on it. It's going to run your new user through all those trees, and it's going to get the end result and actually sum the results from all of them and take the median of that. So that is basically what happens. So the best result that I have was with 350 trees. And with that, I was able to get a split stat score that is 94%. That means that whenever a user goes to the website and buys a product, I can tell with 94% of certainty that he's going to be a good quality customer, a medium quality customer, or a low quality customers. And then we can react on that. So the company started changing. Once that we had the results, the company started changing slowly to have a more data-centric mind. So you start to have questions like, if a low quality customer goes to support, should you give him the same attention that a high quality customer? I mean, is that ethical? Is it not? There was just some of the questions that started popping out once that we had the results in hand. So the cool thing is that with that results, I was able to actually build a platform. Sorry, my bad. Before that, the tools I used. So basically, it was the Python. That's pretty straightforward. Scikit-learn is the library to go if you want to do machine learn algorithms. They had a lot of algorithms in there. It's pretty simple, pretty straightforward. Basically, like applying machine learning into a data is like 4 lines of code. It's not that complex. And also used NumPy to plot some of the graphics that you saw. And in the end, I was able to put all that together into a platform that they can usually use. So all the data that you are seeing is fake, but that would be the predictions, how much they're doing in money, and they also can see the customer. This, for example, is a low quality customer that is right in the blue bottom there. So that become a platform that they can go to and to actually use that data to react to their growth. So before I wrap up, there are a few things that you can't forget, and that is the main point of this talk. First one is data science is awesome. I decided to learn it, and I'm not gonna like play with that because that is kind of hard to learn. I know that it's a learning curve in that, but it's also not as complex as I was thinking it was, and not as complex as most of us think it is. So it's your job to step in. If your company is not into data science, doesn't have a data-centric mindset, it's your job to step in and to help them to have that and to see value in that. The other one is, it's not that hard. I mean, I was able to do that. It took me like 2 months, 3 months working not on business hours. And that is because I was really trying to get the best results. So there was a lot of iterations in that. But it's not that hard to learn and to achieve something good with that. And last, don't settle for untapped potential. That is the main thing that have been pushing me, and that pushed me to learn this and to actually apply this to the company that I was working on. So few small things, TopTal, if you don't know it, and if you're a freelancer, you should check it. That is really good. If you also want to work for TopTal and not be a freelancer, we have a ton of positions open, so make yourself comfortable. For those that are really interested in Elixir, I did Elixir for the last 3 years or so. I'm not doing that anymore, but I still love it. And I have been writing a book so that you can check that on Elixir by Arubis. That is basically helping folks that are coming from object-oriented language to understand a little bit about functional programming and the Elixir itself. So that's really good. If you go to my blog, actually, you're going to find the first 7 chapters of the book posted in there as well. So you can read that and learn that as you go. And that's it then. That's all that I had. Thank you so much. I'm just in time, so I don't know if we have time for questions. So do we have any questions?
Aren't you creating a self-fulfilling prophecy by actually predicting a customer and then maybe giving this customer not that much attention, so he won't probably renew stuff?
Got it.
I mean, there's a chance or a risk that this might happen, or?
Yeah, that a risk that might happen. That score, that 94% score that we got, was actually using the technique that I explained in the beginning. So we spared 25% of the customers that we already had, that we already knew what are the quality, and we used that to test the algorithm. And it got it right 94% of the times.
Yeah, I mean, you can get the algorithms right, but if you actually use it now for a longer period of time, and you actually always classify some customers because they are living in Ohio or Texas or wherever,
yeah,
and you're giving them lower...
You can influence them to become lower customers because you're not given that. Yeah, that's a risk, but that's something that you have to balance. I mean, I never got to the point, I'm not working there anymore, so I never got to the point to see how they are adapting their support and now your other teams and departments to react on top of this data. So I'm not sure what they're going to change, but that's a change that the company must do. I mean, you can, I'm not saying abandon low customer users. Actually, you might have a whole marketing campaign targeting them, trying to make them to become a high-end user. That might be one way of using this data. So that depends on how you react to it. Is there any other questions? There's one there.
Hi. How do you determine the minimum amount, the minimum sample size you need to actually have meaningful results? Because 94% is nice, but with a sample size small enough, it doesn't mean anything.
Yeah. So there is that. I was using 3 years worth of orders. So we're talking about, I think, more than 100,000 orders. So that was a lot. I had some issues with predicting the revenue by month because 3 years is like 36 months. So that is not a lot of data. So when you're saying that you're predicting correctly, like 20% is like 4 months that you're trying to predict. So that was an issue that we had. But with the orders, that was not the case because we did have a lot of orders. If you don't have a lot of, if you don't have meaningful data, then it's hard to get it right with any algorithm that you're going to use because you need to have a minimum data in order to have meaningful results. So yeah, that's a good point, but that was not the case.
Would you have an order of magnitude for this kind of...
That depends on what you're trying to predict. So what I'm using is actually not a classification algorithm. I'm trying to figuring out what is the number. So if you're trying to figuring out the number at a scale, you need more researchers. So you're gonna need more records. But if you're trying to classify, you don't need that many data, but you're still gonna need. So that depends on each case. That's something that you're figuring out as you're trying to learn the relationship between the data. But yeah.
Thank you.
Is there any other question? Nope. All right, that's awesome. Thank you, folks. Have a good one.
Thank you.